This is question number 7. We're told the diagram shows the curve y is equal to x to the 3 over 2 minus 1, which crosses the x-axis at 1, 0, and the tangent to the curve at the point 4, 7. In the first part of the question, for 4 marks, we need to show that the integral from 1 to 4 of x to the 3 over 2 minus 1 with respect to x is equal to 9 2/5. So let's go ahead and do that. We're looking at the integral from 1 to 4 of x to the power of 3 over 2 minus 1, and we're integrating with respect to x. I'm going to now raise by a power and divide by the new power. So we'll have x to the power of 5 over 2 divided by the new power 5 over 2 minus x to the power of 1 divided by 1, and we're interested in this now from 1 to 4. We can go ahead and tidy this up. So if I have now x to the 5 over 2 over 5 over 2, I can write this now as 2/5 x to the power of 5 over 2 minus x, and we're evaluating from 1 to 4. So let's first evaluate when x is 4. I'm going to get 2 over 5. I've got x to the power of 5 over 2. If I take the square root of 4, that's going to give me 2. 2 to the 5th power is going to give me 32. From this I need to subtract 4. I'm now going to subtract away, evaluating when x is 1. That's going to give me 2 over 5 multiplied by 1. 1 to any power is 1 minus 1. So that now gives me, if we look at this, I've got 64 over 5 minus 4, which I could write as minus 20 over 5. And then from here, I'm going to have minus, I'll have 2 over 5, and then minus 5 over 5. So this gives me now 44, so 44 over 5, and we've got now minus, and this is going to give me a total of minus 3/5, so we'll have now plus 3/5, which is going to give me 47 over 5. So 47 over 5, which of course is equal to 9 2/5. I've done this manually without a calculator. I'm sure you could skip a step or two here, but essentially we're just going from there and showing this integral. Okay, in the next part, for 5 marks, it says, hence, find the exact area of the shaded region enclosed by the curve, the tangent, and the x-axis. A couple of different approaches I'm looking at with this one. What I'm going to do is find now the area of this triangle just here and subtract it away. What we've just done is integrated from now the point where x is equal to 1, where we're told that it crosses the x-axis, and x is equal to 4. I'm going to find the area of this triangle right here and simply subtract that away from my answer. So we've got this point just here. We've got 4, 7. What I want to do is find the gradient of the tangent at this point. Therefore, I can get the equation of a straight line and consider where the tangent now intersects the x-axis. Once I've got that, I can find a base of this triangle. I've already got the height. I'll find that area and subtract it away. So what we're going to have then is, the first thing is dy by dx. dy by dx is the gradient function. So what I'm going to do is find the gradient of a tangent at the point where x is equal to 4. So we're going to have now x is x to 3 over 2. We will have now differentiating. This will be 3 over 2 x to the power of 1/2. Or, if you like, 3 over 2 root x. Differentiating a constant will give us 0. So I can write now, when x is equal to 4, which is the point now just here where we've got the tangent, we can say that dy by dx, the gradient of the tangent at that point, will be 3 over 2 multiplied now by the root of 4, which is going to give me 2. So we can see that dy by dx is going to give us 3. If you like, you can say m, the gradient, is equal to 3. I'm simply going to sub this into a straight line equation. Y minus y1 is equal to m, the gradient, x minus x1. So we have the point just here. We have this point here. We've got 4, 7. So y minus 7 is equal to the gradient, which is 3. Then we'll have x minus 4. So this is an equation for the tangent. You can, of course, write it in the form y is equal to mx plus c. I can state now when when y is equal to 0, which is what I'm looking for just here, I want this point right here, we can say 0 minus 7 is equal to, expanding the brackets, 3x minus 12. Adding 12 to both sides, 5 will be equal to 3x, and we can see that 5/3 will be equal to x. So what I've now got is this point here. So I've got the point where the tangent crosses the x-axis. This is going to be now 5/3, 0. I know that this point is going to be 4, 0, and I can see now that I have a triangle. So let's go ahead and work out the area of this triangle. So just jotting down the triangle. We know that the height is 7. That's nice and straightforward to work out. This right here is the base, 4 minus 5/3. So if I wrote this now in thirds, this would be 12 over 3, 0. So this is going to be 7/3. So the area of this triangle will be equal to 1/2 multiplied by the base, which is 7/3, multiplied now by the height, which is 7. So we have 49 over 6. So this now needs to be subtracted from the 9 2/5. So we can say 9 2/5 minus the 49 over 6 will give us the answer. So let's go ahead and do that in the calculator. So we're going to have now, just popping this in, for 9 2/5. So 9 2/5 minus now the 49, so minus 49 over 6. That is going to give us now 37 over 30. So as an exact answer, let's just write it here, 37 over 30, and that will be units squared. So the way in which I've done this is to simply integrate, find the value which we've shown, then find the area of this triangle by considering the gradient of the tangent, continuing the tangent down to the x-axis, getting a value, finding the area of the triangle, and subtracting it away from the integral that we found before. In the exam, keep your workings nice and tidy. I've been a bit all over the place with that, but hopefully it shows that the answer now should be the 9 2/5 minus 49/6 is 37 over 30 units squared.